Here's problem 25 from the 2016 AMC 8. A semicircle is inscribed in an isosceles triangle with base 16 and height 15. So that the diameter of the semicircle lies along the base of the triangle. What is the radius of the semicircle? The choices are 4√3, 120/17, 10, 17√2/2, and 17√3/2. You can pause here and solve the problem before seeing the solution. Let's set up coordinates. Put the base along the x-axis. From -8, 0 to 8, 0. So the base has length 16. The apex sits at 0, 15. Since the height is 15. The center of the semicircle is at the origin. O, the midpoint of the base. First, how long is each equal leg? The right leg runs from 8, 0 up to 0, 15. Its length is the square root of 8 squared plus 15 squared, which is the square root of 64 plus 225, the square root of 289, and that is exactly 17. Now draw the semicircle, centered at O with its flat diameter on the base. Because it is inscribed, it just touches each leg. At that touching point the radius meets the leg at a right angle. So the radius r is exactly the distance from the center O to the leg. Let's find that distance. The right leg goes through 8, 0 and 0, 15. So its line is 15x plus 8y minus 120 equals 0. The distance from the origin to this line is the absolute value of -120. Divided by the square root of 15 squared plus 8 squared. That's 120 over the square root of 289. Which is 120/17. So the radius of the semicircle is 120/17, choice B.